All right, so this is just a quick intro to get you started on the lab. So for the first problem, we're going to assume the following cache. So we're going to have S equals 8, so there's going to be 8 sets, which means we're going to need 3 bits for the set index. E is going to be 1, which means that there's one set line per set, which means we're dealing with a direct mapped cache. So basically, there's going to be one line for every cache set. And then B is 4, which means that there are 4 bytes in each cache line, which means that we'll need to reserve 2 bits for the block offset. All right, so the first address that we're trying to access is address 227 in decimal. So what is the set index tag and block offset for that address? And I've given you a hint here that that number in binary is this number. So take a second, pause the video, and see if you can identify what the set index, the tag, and the block offset would be here. All right, so the diagram here shows the order of these things. So remember, the tag is first, and then the set index, and then the block offset. We know that we're going to need 2 bits for the block offset. So these first 2 bits, the 1, 1, that's going to be the block offset. We know that the set index is going to be 3 bits wide, and that's because we have 8 sets, and so we'll need 3 bits in order to name those 8 sets. And so that's going to be these next 3 bits here. So our set index is going to be 0 because it's these 3 middle digits right here. The tag is going to be these 3 higher order digits. So that's going to be 111 in binary, which is 7 decimal. And then the block offset is going to be these first 2 bits again, which are the 2 ones, which is 3 in decimal. So since we've determined what all those quantities are, you should look at your lab sheet and see if you can determine whether this is a hit. All right, and so hopefully looking at your lab sheet, you can see that obviously this is going to be a hit because we don't have anything in our cache yet. And so this is not going to be a hit, and we're going to have to load the line into cache. And this is how we're going to ask you to write this down on the lab. So we're going to set the valid bit to 1 to indicate that there's now something being stored in this line, in this set. And we are going to set the tag based on the address that we are looking up right now. And then we're going to go load data from the next lower level of memory into the cache. And we don't particularly care about the values that are in memory right now. So we're just going to write it using this notation. So an M and then an index. And the address in the index is going to show the actual address from the lower level memory that's being stored in this particular byte in the cache. So our block size is 4 bytes, so we're going to need to read in 4 bytes. Our block offset here is 3, so that means that block sub 3, that's where we're going to find the actual byte that we're trying to access here at address 227. But we want to read in this entire cache line, and so we'll read in not only this byte, but the other 3 bytes that come along with that line. So we're going to read from location 224, 225, and 226, and place those into the bytes 0, 1, and 2 of this cache line, respectively. Okay, so that's the very first question on the lab. And so then the second one is, well, answer all these same questions for address 226 and determine whether or not it's a hit. And then from there on out, you'll just keep doing addresses, and if something needs to be evicted, you'll have to erase it and remove it from the cache. And so we're asking you to draw in the final version of your diagram what the cache will look like after executing all of the accesses that are at the top of the lab.